conversation. For those that aren't, I would welcome you to join and help us advance the technology that OSGi develops, the specifications and everything that underlie a lot of the Eclipse technology that we see here in this conference. If you have any questions about becoming a member or any other questions about the OSGi Alliance, I would welcome you to come up to myself or one of my colleagues in the OSGi board. I'm sure we'd be glad to talk to you about it at length. In any case, if you looked at the printed program, you know that this is a replacement talk. We're very, very lucky to have high-quality talk. I think we've got and Luis Festas Matos from BVP.
BVP, yeah.
BVP, it's harder than one, was the lead developer for their GMP Integrator product. He has extensive knowledge in financial messaging, and that product, the GMP product, the GMP Integrator product, is an OSGi product. I'd like to welcome Luis this morning.
Thanks.
Thanks again.
Thank you. So if you came here not knowing that this was not OSGi my way, you won't be disappointed. Because basically we did OSGi our way, yeah? So it was actually a very, very much tortuous path that we got to get OSGi working in our company. And we do financial messaging. So I'm Luis Festas Matos from BBP GmbH. This is in Switzerland. This is a little about me. So I'm Brazilian from Rio de Janeiro. Java engineer since 2002. OSGi addict since 2010. I like samba, hot weather, and beaches. So very much the Brazilian type. But I live in Switzerland. So basically, yeah, things happen, yeah. So these are my contacts. Afterwards, I have here a line for people if they want a copy of this presentation, they can leave their emails. So a little about my company. The BBP Group exists in Switzerland, UK, and Germany, and it was founded in 1984. And we are in Switzerland, in Great Britain, Germany. We actually belong to a corporate called D&H now. And we have 2 data centers in Switzerland and Great Britain because of problems like if a bomb comes on Switzerland, we have Great Britain. If it goes to Great Britain, we have Switzerland. Yeah, basically that's it. And we are the largest Swift service bureau worldwide. That means that we make the most transactions per day in Swift. We are all over the world, basically. So this is only BBP, not D&H, but we have customers everywhere. Basically banks, corporates, clearing houses, all kinds of customers. These are some of the financial institutions that we work with, corporates like ABB, Swiss Life, Hydro. These are the automated clearing houses. Automated clearing houses buy our software and run it. Yeah? We run our own software as a service bureau. They also buy and they run it themselves. And here some service providers. Yeah? European Bank Clearing, Bank Giro, these are also customers from us. So our software, the software that I am going to talk about, is a part of the software of our company. Basically, it's the core. It's the core of the company. So there is, for example, web part. There is the other parts like bank backends. But this, what we are talking here, is the core. It's from where the messages are coming and going. Yeah? We connect to our own backend. We connect to corporate straight-through processing, to bank through processing systems, to Swift network, to Fed and Chips network. These are networks present Fed and Chips in the US and other networks. There is, it's very difficult to talk about all of them here. Yeah? So, but basically we have our core, we have some connectors developed which connect to the core, and then we connect to our own software or to other places, to other softwares. Here is a better way of seeing this thing. So basically here is our core again. Here are customers, STP, so STP is straight-through processing hosts. Yeah. This is some of the qualities that we have. We convert messages. We don't allow duplicate messages. We cannot afford to lose messages because if a bank, for example, sends 1 million to another bank, we cannot lose it. Yeah? Otherwise, we have to pay the 1 million. Yeah, so not so good. We must log every message. We must have automatic recovery. So all of this we have to implement in our OSGi core. So we make interface to hosts. We make interface to our own applications, which are developed in JBoss. We have security alarming managing systems. For example, if Osama bin Laden wants to send something, our software can catch it and send an alarm to an iPhone or to something. Then we have, here are some softwares that we have, like this global compliance is the software that checks if there is something suspicious. Reconciliation software to see if one bank sent to another things and if the other confirms. So there is a lot of softwares here from our company, but basically the one that I'm talking about is this one. Yeah? And then we have connections to the interbank financial services like Swift and others. And in the end, we have users. So if somebody wants to make a manual message, we also offer this possibility, or to check which messages were sent. So we have Tomcat and Zcos here, and the users can connect to the backend and then to our OSGi core. The performance that we have per OSGi core is 400,000 transactions per hour. We can have up to 10 cores, so we can actually reach 4 million messages per hour at the moment. And the platforms we are working is the Linux in general. Yeah? So this is the software we had before in our company. It's our Prehistoric Software. It had a limited customer-friendly API because some years, so 15 years ago, nobody was thinking of connecting externals to cores. Yeah? So basically, it was done in C++. It was just adding things. You know, we were adding things to this as we needed. We had a non-scalable software, so maximum we could connect 2 cores together. Yeah, the architecture couldn't reach more. We had a fat Java client, so basically customers had to go and download, and we used that. And it was not fast enough. We could reach basically 1 million. Yeah, and customers were crying for something like 5 years ago already for 5 million messages per hour. And it was reliable. It used some techniques, but it wasn't transactional. So you couldn't guarantee that a message would really go out without doing a lot of tricks. Yeah? We did the tricks, and it was reliable, but it wasn't transactional. So then in 2010, so we got our requirements. That was when we started to do this software. It must be faster, but keeping the same level of stability of the previous one. It must be automated, but customizable. Yeah, that's something that you hear a lot. It's horrible to hear. If it is automated, shouldn't be. But also transactional, and we should keep the same record of no message loss. It must be scalable vertically, so you have to be able to add more. It must be able to be faster if you increase the power of the machine. It must have continuous integration tests, so we must be able to pass tests, even tests that customer sends to us. It must be easy to maintain, easy to deploy, extendable by customers, and we must keep virtually 0% downtime because the banks don't like when you just say to them, look, we cannot send you messages right now. Yeah. It's not really an option. So we cannot actually go to the 0%, but you see here the numbers. Yeah? We reached something like 0.02% downtime in 2012, 2013, 0.01%. These are very low numbers. So actually, when we heard of that, we thought that people wanted like a Christmas present, right? It should also make free coffee, guess lotto numbers. Yeah? That should be what the software should do. We were like very confused, and here you can see our faces on 2010. So everybody in our team was like, okay, it must be open source. We have to have support from these open source vendors, so you cannot just choose anything. It must be automated and customizable, which normally are things which are one against the other. It must be lean, it must be fast, it must be easy to maintain, and vertical and horizontal stability. So this was like we started with these phases, looking and seeing what should we do. So we made a lot of proof of concepts at that time, and we lost a lot of time with this. At that time, the service mixed with JBI and NMR and REJPA was available. It was too slow. We couldn't reach our numbers with this. Then we tried the JBoss with JPA and JTA, too slow, and it was very difficult to scale with our requirements. Then there was Spring DM, which died. And then there was this namespace and class loader problems that we couldn't really actually work with. Then we tried for persistence Cassandra and CouchDB, like NoSQL DBs. And it wasn't XA transactions ready, so we couldn't really use it. Then we tried rules as a way of being customizable. Again, too slow. So you see that we were really desperate. We tried Hibernate. Hibernate, we couldn't put it on OSGi. And everything that was enterprise Java, we couldn't use. It was just too small. Too slow. Yeah? Too heavy, too slow. So we had workshops with Fuse, with Jeff Genander. Maybe some people here know about him. And Adrian Treneman. So these were people who came up to help us with this mess, yeah, basically. So we had some survivors from all these tests, yeah. Not all was so bad. So we had some survival software here. We, as support, we started working with Git, Maven, Jenkins for the tests, automation tests, with Eclipse for the development, and Mockito for other tests, so different integration, and these are like unit tests. The development tools that we used, so these are the ones that passed, yeah, after all this mess. So we started using Camel, ActiveMQ, they are transactional. The Karaf had just come into play 5 years ago. We started using Karaf and we were happy with it. Hazelcast for data grid, and Atomicus for transactions, XA transactions. Then for customer customizable stuff, we used MVal. For fast POJO to JSON, JSON to POJO connections, we started using this JSON ARIs we use as the blueprint XML, and basically everything runs in OSGi. Yeah? Everything which is here runs in OSGi. And then for database systems, we use this Ingress, which is just for historical reasons, and Oracle and H2. So all of these are transactional databases, and Linux. So this was the stack that we got in the end, yeah? That we are still working with now. Then we had to reach some decisions how to use all this software. So transactions, we started using the XA. Yeah? There is no JTA in our application. So Camel, ActiveMQ, any database which is transactional, Hazelcast and XA, we use as XA resources. Then we had to develop basically our own non-SQL-like lean persistence layer with no JPA. So here, the thing is, it's non-SQL-like, but it runs on SQL databases. Yeah? It's just that all our software doesn't trust anything to do with relational databases. Our layers are non-SQL. We actually, in the end, connect to our SQL database, but we don't care about it. Then we used Camel for the main routes connecting the services, the OSGi services. MVAL rules for customization. Hazelcast for inter-Karaf distributed data. Hazelcast actually now is transactional. It was something that we made Hazelcast do. Karaf features for provisioning, which makes it very easy for us to deploy. And Blueprint XML, so injection and service creation lifecycle, always done by Blueprint. And we have 0% annotations on any service, on any processor. And then here, this was a hard decision. We had to separate the processing database from the querying database. This is actually connected to the fact that we have a non-SQL-like lean persistence. So if a customer wants to see what's going on, we send a message to another database, and there he can do 500 index if they like. But here, it's key value. We have key value. It's just key value. It's very fast, and it also works, for example, in Oracle, that you have only a key, a value, and you reach and get it. Yeah? So Oracle is actually very good, and it compares to a non-SQL database if you leave Oracle just with one index and one value. So there is one index per table on the processing database, and then we send a message, and there is a querying database, and then you can do whatever you like there. So here is a bit of showing how the architecture is. Here we have the host from the customers. There is the financial services. There is our connectors. We connect to an ActiveMQ network of brokers. Then we go to, here there is Camel consumers, basically, and they are consuming from ActiveMQ. This is all transactional here. Yeah? So what happens, for example, if we send a message from Swift, it goes to the network of brokers, it goes to the Karaf, then the Karaf just goes boom. What happens then? The message disappears, it comes back to the network of brokers, it goes to another Karaf, it's consumed again, then it goes back, and goes to a host. So that's how it works. That's what we mean by transactional. Yeah? You can, the message which anywhere here gets, yes?
You mentioned that we don't use JTA.
Yes.
I wonder how you do the transactional part without JTA, because in the camera route, you would, if you want an XA transaction, you would use a JTA transaction.
We use just, we connect with the JTA interface, but we are actually using behind is an XA Atomicus. Yeah? So it's the XA Atomicus which is there. Yeah. So basically, we use the infrastructure, but what is the implementation behind is the XA resource. So here we have how it works. So basically, I was saying here you have what happens. If anything happens, the message goes back to the broker at any time. And here it's a more detailed way of seeing the message flow. So basically, you start here from ActiveMQ. You have an XA transaction. There's a consumer here. Then here you have services. So I'll just show you, for example, here are the services, these ones. The green ones are the services. Then we have these blue ones here, which are places where MVAL rules come into play, yeah, for customization. So here are the MVAL rules places. And then it just goes on. These are all services that we actually use: priority assignment, duplicate detections, authorization. Then here we have a transaction workflow where we have some automated things, and the customer can add their own stuff. And then here on the workflow, we actually save to the database, and we send to the querying database something if there is any change. Here, Hazelcast comes into play, for example, so that this information, if it is needed, it is seen by the other Karafs as well. And then afterwards, here you have again some MVAL rules. So one message can have many destinations: a printer, outside, QueryDB. And here, if everything goes well, the XA transaction is finished. Yeah? And then everything is fine, and we got our message through. And here you see these red ones are where the camel routes are being used. So we actually connect camel as a main path through the application, and the MVAL rules are used as differentiators, customizable places, and so on. And here I'll talk a little about what made our works, for example, different from other works. So we use JSON. We use this little software here, which is open source, JSON schema to Pojo. Actually, what happens is you create your own JSON descriptions of DTOs, and this gives you some Pojos. Yeah? Then we use, when we do these Pojos, the tables that we have, which we call collections, are inferred directly from the Pojo definition. So we don't really actually do any table. The tables are all created automatically. We have annotators which create some advanced JSON annotations on the Pojos. It is very fast. This we have tested a lot. These it's on-the-fly JSON to Pojo to JSON conversions are very fast. We are using this Jackson data bind from Faster XML, and we actually contributed some stuff for Faster XML to make it OSGi ready. Yeah? So this is used in intra-process communications. We JSONize everything and send it over ActiveMQ. It is used in our key value non-SQL-like persist. And this makes it very fast to send messages over the network. Then we have our interface layer. So here you see, for example, this is a place where we persist something. The definition of our table is this. Yeah? This creates, basically this annotation here creates our tables. Our tables are all automatically created based on the place where the persistence is being done. Here you see, for example, an interface. You will see that it is a very bare interface. You have put, get methods. It's very simple. Yeah, it's meant to be fast. It's not meant to be fancy. Fancy, there is the query database. So it's a bare map-like interface. and we need it for speed. That was the main thing about this. With the transactions, we got every resource that we have as an XA transaction. We actually making cutting edge technology. This looks cool, but it's not cool. Because you have actually to be working with the, the latest thing that the people are doing with the snapshot releases, helping them sometimes to change code, pushing vendors like Hazelcast to be full XA ready, which they weren't, and in close collaboration with Atomicos, which is this company that makes the XA transactions, and with Hazelcast. Yeah? Up to this day, we are still talking with them, still looking, look, we want this, we need that, and so on. So the resources that we use is, as I said, Camel, the databases, ActiveMQ, and Hazelcast. And we are always doing tests. Yeah? There is tests like pull the plug and see what happens if the machine just disappears. What happens if we have a recovery of a transaction while the system is online? What happens if the system is restarting and there is a recovery going on? There's a lot of stuff like that. Then flexibility. For flexibility, we have version MVAL rules. So these are like MVAL rules. The customer can actually create their own MVAL rules. Of course, customers are not very keen on going into Eclipse. Yeah? So basically, we have a friendly GUI for BPMN to MVAL conversion. So here the customer is happy and he can use some GUI and make some beautiful processes. And we change it to to MVAL. Yeah? And the thing is, new rules can be added without downtime at any time. And then you just have to switch between the old rules that you were using and the new rules. Yeah? So here we come to the conclusion. We actually made it into open source based and with support contracts in every vendor. We have no message loss with tests that we make and with customers. We have transactional with XA. It's very fast. And it's actually something that surprised us to get, we wanted all our cores together to be faster than the C++ 2 cores. But actually what we got is core to core, we are getting faster than the C++ based core, yeah? Which wasn't our objective, but it's cool, it's good. Yeah. It is stable, we are getting downtimes around 0.01% of the time. It's customizable with MVAL rules. And we have an automated basic configuration so the customer can out of the box start working. It's a lean architecture because it's OSGi based. And it's vertically and horizontally scalable. So Karaf has this capacity itself, ActiveMQ as well. So we just didn't make it on the brewing coffee or guessing the lotto numbers. No? Nothing's perfect, but they are happy like that. So basically, if you have any questions, I'll be happy to answer. And I have here a place if you want this presentation as a PDF, you can leave here your email.
Also, we will be posting the presentations from the OSGi community event. So anything in the 2 OSGi tracks from the prior 2 days and this morning those will be posted as well. But certainly that's going to take us a little bit of time. So if you want it right away, you might want to leave your email with me.
Mm-hmm.
So Luis, we have time. We have about 5 minutes for questions. I see one in the back. Please.
Yeah, I was curious about where your experience is in terms of the network broker related latency, and how do you cope with it? How do you improve the latency involved with this network? what was your experience about it?
Yeah, basically we got, that was one of the reasons this Jeff Genender came. We had the network of brokers, or XMQ is not easy to configure, basically. Yeah? So we had a lot of problems in the beginning. That was right in the 2010, 2011. And there is some, so if you, the fetch that you do with the XMQ has to be very well tuned, you know. There is some options that you have on ActiveMQ about how to use KahaDB. If you are, there is 5 or 6 different things that you have to configure there. I can actually, if you leave your email here, I can send you what we got as conclusions, yeah, from this place, because it was really slow and it wasn't performant at that time, and we had to get it working. And then Jeff came from the US and he was with us for 1 week helping configuring that. You know?
Yeah, so I think that we had the same problem, because as soon as we set up the network of brokers, our latency skyrocketed. So
yeah, exactly, because you have to, these parameters, fetch, KahaDB, how to use, you know, if you use transactional, you use transactional. Yeah. ActiveMQ. If you use transactional ActiveMQ, there is an option to pre-fetch that you have to do, you know. Otherwise, it just doesn't work at all. So there is like this, say, 6 options that you have to put there on the XML from the ActiveMQ. Without this, it just doesn't work. Yeah, that's it. But yeah, leave your email. I can send you the conclusions we got at this workshop with Jeff. Yeah.
Do we have any other questions for Luis? Yes, please.
You mentioned the Matos transaction manager.
Yeah.
The default transaction manager in Karaf, Geronimo one. Did you compare the two? What are the results?
Yeah, we actually compared. So we had something like 3 or 4 transaction managers that we were comparing, and the Atomicos came up as the fastest. That was the thing that we needed.
Was it mostly about speed or also problems with
The problems with the no, we didn't have like problems like it doesn't work, but we had problems like we cannot reach 500,000 messages in one core. Yeah? That was our biggest problem. It was something like 1 for 5. Yeah, it was really bad. we could do 100,000 transactions per hour, and this we couldn't work with this. Actually, J2EE in general, that was our problem. Just we are not against J2EE. I think it's pretty good for, you know, if you are not in financial messaging. If you don't need this speed desperately that we do, because we actually have to give up a lot of things to get to this point. Yeah? So giving up J2EE just because nothing, yeah? We had to do it because of speed, not because of anything else. Yeah? The architecture is good, but it's too slow.
Another question.
Nothing. 0. There is not a lot of decisions on Camel. We are using Camel mostly for binding OSGi services. Whenever you need very quick decisions, then we have routings. And the routings have nothing to do with Camel. It's all MVal based, and MVal is really fast. Yeah? MVal, you can write your own scripts on MVal, and it's really fast. Here on the destination mapper, on the routing, on the application flow selector, these are key points of the application, and here we have MVal. And what we are actually doing is to get a GUI based for the customers to write their own beautiful things, and then turn it into MVal. Yeah? So, yeah. Anything else?
I asked a question. Okay.
Yeah. What was your final throughput in terms of message per hour or message per minute?
So we basically doing per hour 400,000 transactions per core, yeah? And we have reached at the moment 4 million transactions per hour with all cores together. We actually have to reach 5 million. Yeah, that was our RFP. But we reached 4 million and our customers are happy now. Yeah. This 5 million was for Citibank, and Citibank is using something else right now. And but for example, for almost any bank in the world that is not Citibank, 4 millions per hour is really good. Yeah. So we are doing 4 millions. We are trying to reach the 5 million, yeah, because that's the thing that we have to reach, let's say, for our bosses to be happy, but still 4 million is good. Yeah. We had actually 1 million before. We are 4 million now. Yeah. And there is a point where if you add more OSGi cores, that doesn't help. Yeah? So you have to do it some other way. Maybe taking off camel. Who knows? Yeah?
Well,
so there is still a lot of research going on.
Luis,
yeah.
Thank you very, very much for an excellent presentation.
Thanks.